Ohm's law. We use electricity in our daily life for various applications. For example, to light bulbs, to heat an electric iron, and operate refrigerators and air conditioners. All these applications require different amounts of current. Find the most efficient way to get the proper current. Ohm's law is used. Ohm's law was derived experimentally by the German physicist Georg Simon Ohm in 1826. According to Ohm's law, the electric current flowing through a conductor is directly proportional to the potential difference across its ends, provided the physical conditions such as temperature, pressure, etc. of the conductor remain the same. Principle: if I is the current flowing through the conductor and V is the potential difference across its ends, then according to Ohm's law, V is equal to Ri, where R is the constant of proportionality. It is known as resistance of the conductor. Or V by I is equal to R. Knowing the length L and radius R of the resistance wire, Rho is equal to pi r squared R divided by L, gives the resistivity of the wire. So here we are determining the resistivity of a given wire by plotting a graph of potential difference versus current. Materials required: battery eliminator, ammeter, voltmeter, a resistance wire, rheostat, one-way key, meter scale, screw gauge, connecting wires. Procedure: arrange the required materials according to the circuit diagram. The positive terminal of the battery is connected to the positive terminal of the voltmeter, which is connected in series with the ammeter. Through a key, the connection can be extended to the upper terminal of the rheostat, whose lower terminal is connected to the negative terminal of the battery. The given resistor must be connected in parallel to the voltmeter. Determine the least count of voltmeter and ammeter and also note the zero error. To check the connections, insert the key K, then slide the rheostat contact and see whether the ammeter and voltmeter are working properly. By adjusting the sliding contact of the rheostat, note down the value of the potential difference V across the resistor from the voltmeter and current I from the ammeter. Repeat the experiment by changing the rheostat slider position. In each case, V by I is calculated, which gives the resistance R of the resistor, and it is found as a constant. Cut the resistance wire at the points where it leaves the terminals, stretch it and find its length by the meter scale. Measure the diameter of the wire using the screw gauge. A graph is drawn with I along the x-axis and V along the y-axis. The graph is a straight line. This also verifies Ohm's law. The slope of the graph will give the resistance of the wire. Note the values of OB and AB, then calculate the value of R as AB by OB, which gives the value of unknown resistance. We can now calculate the resistivity of the material of the given wire by using the equation Rho is equal to pi r squared R divided by L. Applications: Ohm's law is used to design various electrical circuits and amplifiers. oscillators, power generators, etc. It is also used to figure out the correct resistors to maintain proper current in a circuit at given voltage.